Éclépans is an area north of the Lausanne lake in Switzerland. Swiss Geo Energy wants to build a geothermal plant to deliver heat and power to the people of the area. This 3D survey will be used by our geologist team and our geophysicist team to build a detailed structural model of the area. And the potential that it can unlock, I find it just amazing.
Well, just being involved in something that is, I would say, important, not only for me, but for the future, for our community, and I think it's quite relevant.
We have 4 fleets of vibrators that will go on the field, and so we need to plan them in order to be sure that they have enough points to acquire and that they have enough, not too much distance to cover. We have these lines, and all the lines, the points are automatically then dispatched in order to be shot. And now you see, for example, here the yellow lines, it's the production line. The blue line, it's only the transit.
We plan the operations, making sure that we go into villages as early as possible during the night to limit the disturbance. There are operational advantages, but there's also a big advantage in terms of data quality, because all the anthropic noise is much lower at night. What happens next is that these data have to be processed, they will be filtered, denoised, they will be stretched and squeezed and moved and finally migrated to create the subsurface images. We have already seen samples of the data from multiple nodes that were harvested and are collected daily, and the data quality looks excellent so far.
The Stryde node is the world's smallest and lightest seismic receiver node. The way we've achieved this is by focusing on really the most fundamental elements that are required to acquire high quality seismic data.
So this is a 3D seismic acquisition project, and we deployed already on the field around 21,500 sensors. We are going to shoot more or less 15,000 vibration points.
It's a great example how Stryde can help a renewable industry of that importance to acquire the data they need in an urban environment like this one. Probably what struck me the most, just walking with the acquisition team last night, it was to see the level of acceptance and communication that have been passed to the locals.
We expect the activity to increase and to keep on increasing in Europe around this type of seismic activity, which is the only geophysical technology that can provide enough accuracy to properly develop geothermal production.
We're hoping that with this project we are showing how it is possible, safe and effective to acquire modern, high density, high productivity seismic data, even in challenging environments such as semi-urban areas in Europe.
This is maybe the beginning of a very successful story, in the sense that if we succeed in a couple of years, making the most of the data, drilling exploration well, confirming the potential, building a geothermal plant, we think that we can replicate and scale up this concept in many different areas of Switzerland, and therefore contributing to the energy transition in Switzerland.